2021 Pure Mathematics, paper 1. Question number 1. Given that x minus 1 is a factor, so if x minus 1 is a factor, x minus 1 equals 0, and you take x1 to the right, so x equals to 1. So you substitute 1 into the expression. So f of 1 has to be equals to 0. So you substitute 1. So we have here 1, 1, 1. And you make all of that equals to 0. And you solve it, you get a equals to 3. So you can replace a with 3. And then here it would be 3 times 3, it gives you 9. Question number 2. It wants us to express f of x in the form x plus a all squared plus b. So we want to complete the square. So you find half of 4 is 2. So you got x minus 2, you square it. And then you subtract the 2 squared, and then you add 5. So that's the process for completing the square. And minus 4 plus 5 is the same as 5 minus 4. You put that in your calculator, you get 1. So a is minus 2, b is 1. Part B, write down the coordinates of P. The coordinates of P is where it meets the y-axis. When it meets the y-axis, the x value is 0. So put x is 0. And when you put x is 0, you solve it, you get y to be, you get the coordinate to be 0 and 5. So what you do, you put 0 there, put 0 there, and then get 0 and 5. And part B, part 2, the coordinate of Q. Q is the minimum turning point, and you get it from the completed equation. You use 2 from there, and you use 1. So it's 2 and 1. For those who have with a graphics calculator, when you plot that graph, you put it there, you see that's where it crosses the y-axis, 0, 5. So the coordinate 0, 5. And you also, when you plot the graph, you also see that's the minimum point. The point there is 2, 1. 2, 1. So the calculator gives you the minimum point. Question number 3. Show that 3k squared minus 58k plus 240 equals to 0. So we start by substituting values. So we know u1 is equals to 2. So to get u2, it would be k minus 24 over u1. And that will give us k minus 2. To get u3, it will be k minus 24 over u2. But what is our u2? Our u2 is k minus 12. So put k minus 12 there. So we got that for u3. And then we want u1 from the question, u1 plus 2, u2 plus u3. So that's u1, u2, we double it, plus u3. Put that together, 2 minus 24 is minus 22. 2k plus k is 3k. We'll start with that expression there. We multiply all of them by k minus 12. Multiply 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 by k minus 12. That will get it to this linear form. And then you would expand and solve it, and then you will get that quadratic. To solve the quadratic, put that in your calculator. you get k is 6 and k is 40/3. But you choose k equals to 6 because they say the answer is an integer. So you choose k equals to 6 because the answer is an integer. So what is an integer? It's good to know what an integer is. So if we have integers there, we can have negative numbers and whole numbers. They're all integers. So negative numbers, all the -1, -2, etc. And the whole number 0, 1, 2, 3. So, and we have natural numbers and 0. So integers are all of these: -4, -2, 1, 0, 1. Those are all considered integers. Part C says find the value of U3. We got the general formula. U1 is 2 and K is 6. So we would substitute for U3. We'll substitute K is 6. And then put that in the calculator. You get U3 equals to 10. Question number 4. Show that alpha is a solution of the equation. The curve with equation has a single turning point, x equals to alpha. So we're going to be using some of these formulae. We're going to be using the chain rule, and we're going to be using, when you differentiate ln x, you get 1/x. And so the chain rule and differential of ln x, those are the two things which you need to remember. We're going to use them for this question. So for part A, let's imagine this part I put in yellow. Let's call that u. We're going to differentiate that. So f dash of x, that means differentiating. When you differentiate x squared, you get 2x. When you differentiate ln u, you use that chain rule. So you differentiate the inside, differentiate 2x squared, you get 4x. Differentiate 4x, you get 4. And then you divide by the original. So it will be 2x plus 4x minus 4 over 2x squared minus 4x plus 5. Now you multiply all of them by 4, 2x squared minus 4x plus 5. And you get this linear expression. You put them together. Make sure this 10x plus this 10x gives you 14x. And then you divide everything by 2 to get the expression. The iterative formula, which is given there, is used to find an approximate value for alpha. So we want to calculate to 4 decimal places the value of x2 and x4. It tells us that x1 is 0.3. So we substitute 0.3, and then you get your answer to 4 decimal places, 0.3294. And then we take that 0.3294, substitute it in the next one, and it gives you the answer 0.3375. x3, and then we substitute that again to the next one, and then it gives you the answer for x4. So that's your answer for x3 and x4. For part C, it wants to show that alpha is 0.341 to 3 decimal places. So we can substitute h of x is equal to that expression. So if we put h is 0.3405, we get minus 0.00130. We put h of 0.3415, we get that. So it changes sign from negative to positive. From negative to positive. So we would say there's a change of sign, and f of x is continuous. Change of sign and then continuous is required. So between 0.3405 and 0.3415. So alpha is 0.341. where did we get this 0.3? We use the lower bound, and we use that upper bound. So between the lower bound and the upper bound, the answer there was negative. When you put that, it was positive, so there was a change of sign. Question number 5, part A. Show that the profit for year 3 would be 23,328. Write the formula for the n term. You start with 20,000. The common ratio is 1.08. And it's for 3, profit for year 3. So 3 minus 1. So the profit in 3 years, n minus 1. So 3 for n minus 1. You put that, get that answer. How did we get 1.08? You do 100 plus 8. It gives you 108. And 108 divided by 100, 1.08. We get the multiplier. And that's the formula for geometric sequence, the n term formula and the sum of the n term. Those two. Number 5, part B. Find the first year when the yearly profit exceed. Exceed means greater than 65,000. So we have the n term expression is given there. So we want to find n. Solve that equation to find n. So we don't need to do trial and error. By trying different numbers for n, we can use logarithms. So we divide by 20,000 on both sides. And then you put log and power to the front. So the n minus 1 will come to the front. So we're using natural log in this case. And then you divide by ln 1.08. And then you add 1 to both sides. So you got 16.31. But you cannot have 0.31 the first year. Want the whole year. So it has to be bigger. So that's why we choose 17. Part C, find the total profit for the first 20 years of trading, giving your answers to the nearest 1,000. So A is 20,000, arrow is 1.08, N is for 20 years. Put that in that formula. And this is the formula for sum of N term underneath there. So A is 20,000, arrow is 1.08, N is 20. And that gives you that number there. To the nearest 1,000, it's 915,000. For question number 6, they want us to find AC. So to go from A to C, you can go from A to B plus B to C. Do we know A to B? Yes, that's A to B. Do we know B to C? Yes, we put that. We add them together and you get AC. Minus 3I plus I, it gives you minus 2I. Minus 4J plus J, minus 3J, and then minus 5K plus 4K, it gives you minus K. For part B, we're going to use the cosine rule. And the one we're going to use for that is the one at the bottom there, where the cosine of the angle is equals to B squared plus C squared minus A squared over 2BC. So what we do now is we have to just rearrange it. We know what, we have to find the magnitude for each of these sides. So we substitute AB squared as AB squared there, and BC squared, and we rearrange it to get cos A, this ABC, the subject, which is that angle. So that will be that. Using like the formula above, and you get 9/10. Question number 7, you have an equation of a circle. Find coordinates of center and the radius. So we have to use some algebra to do this. Let's pick the ones with x. We have x squared and we have minus 10x. If we take half of 10 is 5 and we multiply it, expand it, x minus 5 times x minus 5, we got x squared minus 10x plus 25. So we got the x squared, we got the minus 10x, but we got the plus 25. So we have to remove that 25. That's why we have minus 25 there. We use the y part, y squared plus 4y. If we take half of 4 is 2, and we expand y plus 2 times y plus 2, you get y squared plus 4y plus 4, which you got that y squared, you got the 4y, then we got the plus 4, which is the excess. That's why we remove the plus 4. Now we put all the numbers. We take the 25, the minus 25 minus 4, 11 to the right, it becomes 18. So minus 25 minus 4 plus 11, it gives you 18. So the center is 5 minus 2. Be careful when you find the center. If it's minus there, it will be positive 5. If it's plus there, it will be minus 2. And the radius is square root of 18, which is 3 root 2. You can also use this formula, and this to find the center, and this to find the radius. The line L has equation y equals to 3x plus k. So find the possible values of k, giving your answers as simplified surd. L1 is a tangent to C. C is the curve there, the circle. So you can see a tangent. I've drawn a tangent line there and another tangent line. So there's only those two tangent lines that way. You can have two tangent lines the other way with positive gradient. So what you want to do, you want to take 3x plus k, replace y in that formula for the circle, and then you will get a quadratic. And then you'll be very careful when you do the quadratic because it's a tangent. B squared minus 4ac equals to 0. So first of all, identify A. A is 10, B is 6k plus 2, and C is k squared plus 4k plus 11. So make sure you know B, A, B, and C properly. Put that in that formula for B squared minus 4 times A times C. And then you will solve the quadratic, you'll get those two answers. And use the graphics calculator to solve the quadratics to get the two answers. Question number 8. They want us to find a complete equation for the model. So we need to find, we put at time equal to 0 at the start. When it's at the start, the time is 0. And n is 1000. So you put 0 for t, and then you get a to be 1000. And when the time is 5, n would be 2000 equals to 1000 e to the 5k, and you solve that, you will get k to be 1/5 ln 2. Where did we get 2000 from? The question says the population doubled. So 1000 times 2, that's where the 2000 came from after 5 years, after 5 hours. But B, find the rate of increase in the number of bacteria in this population exactly 8 hours from the start. Give your answer to two significant figures. So when T is equal, the rate of increase, so we have to differentiate. Rate has to do with time. So differentiate the n over dt. So when we differentiate, 1/5 ln 2 comes to the front, and then 1000 e to the power 1/5 ln 2 times t. Now you simplify that with your calculator, you can put t equals to 8. Put t equals to 8, and you put down your calculator, you get 420 to 3 significant figures. So for part C, we have to find the value of t. So we have this expression there, which is, that's the one for m there. And we have the one we did from before. So because we make them equals to each other, we want to solve that. So what we can do is we can start by crossing out the 500s. This one will be 2 there, and that's why we got that 2 there. And then we put log in front of them, and we have 2 times that. When you multiply with log, you separate them and add them. So it's log 2 plus log of that. And then power to the front, this comes to the front, and the log e will cancel. And from there now, you can have log 2 plus 0.2 ln 2 times t log e. Log e will cancel there. Put 0.2 ln 2 to the left. It becomes minus 0.2 ln 2. And t is factorize t out. And after that, you divide to get that expression. Put that in your calculator, it gives you 12.5 hours. So be careful how you put in the calculator, you get 12.5 hours. So you're just solving the equation. The left-hand side equals to the right-hand side. We solve it for t. Question number 9. Part A, find the value of B and C. So to express it in partial fractions, we have A, B, and C. And because what we have to be careful, 5x plus 2, we write it the first time. And then we write it again, 5x plus 2 all squared. So when you multiply by this denominator, you will get this second expression. To get it equals to 0, we can use 1 minus 2x is equal to 0. And that'll give us x to be a half. So we use x to be a half. Substitute x to be half there, half there, half there, half there, half there, half there. It's a lot to simplify. And that gives us c to be 2. So we'll get c to be 2. And then we now substitute minus 2 over 5. How did we get minus 2 over 5? We can use 5x plus 2 equal to 0. Take 2 to the other side, it becomes minus 2 divided by 5 is equals to x. So that would make this one to be 0. So substitute minus 2 over 5, and we'll get b to be equals to 1. And then we can pick a number that is easier to work with, 0. You can substitute x equals to 1. I like to use 0. So you put 0, you will work out a to be equals to 0. So if you put 0, you get a to be 0. So since a is 0, that will disappear. And you're left with b is 1 and c is 2. To check if it is correct, you will do the single fraction which is in blue. In the graphics calculator, you'll get that shape of the graph. See the up part for the graph and the bottom part. And then when you split it into 2, the red one at the bottom, there's the 2 fractions there. You plot it, you will get the same shape. If you compare these 2 shapes, they're exactly the same. That means you have split it in a partial fraction, your answer is correct. We're going to use this formula for binomial expansion. It's important to note this formula and this information. Use binomial expansion to show that in ascending powers of x, f of x is that. So what we want to do, we have 1 over 5x plus 2. We take it to the numerator, 2 plus 5x to the minus 2. Now we have to change it to this form. And the minus 2 goes there as well. So 2 to the minus 2, and then we'll have 1 plus 5 over 2x to the minus 2. Change it to this form so that we can use that binomial formula. So 2 to the minus 2 is outside, and then we use the formula, substitute in. 2 to the minus 2 is 1 over 4. So you remove the bracket, expand, and you get this expression for equation 1. Now we do the same for the second factor. 1 minus 2x goes to the numerator, becomes 1 minus 2x to the minus 1. We use that binomial expansion formula for this one. Remove the brackets, we get this equation number 2. So f of x means we add them together. So we add equation 1 and equation 2. So when you add them, you get that expression at the end. So it's just to take your time and make sure you don't make mistakes when you add or multiply. So for the part that says find the range of values for which the expansion is valid. So we need to find a range where each expansion is valid. So what we want to do now is to look at the first one. Is valid for, we're using this expression there, this one to work it out. It's valid for absolute value of x is less than a over b. So we're using this one. That's a there, that's b. And for the next expansion, absolute value of x is less than 1 over 2. So we want to put them together. So for the first one is, this one is valid from 2 over 5, minus 2 over 5 up to plus 2 over 5. And the next one is valid from minus a half up to plus a half. So we want the one that covers the both range. So it's this one. So to choose less than, absolute value less than 2 over 5, or you can write it as from minus 2 over 5 less than x up to less than 2 over 5. Question number 10. For question number 10, we're going to use the double angle identities, sine 2 theta, cos 2 theta, different form. We wouldn't use the half angle. So we're using the double angle identities that they are. There they are. So for 10a, we have to replace cos 2 theta. We replace it with 1 minus 2 sine squared 2 theta. We replace sine 2 theta with 2 sine theta cos theta. So that's one way you can look at that. And then you replace cos 2 theta with 2 cos squared theta minus 1. And replace sine 2 theta with 2 sine theta cos theta. So we have here 1 minus 1 will be 0. It's minus 1 here times minus 2. It becomes plus 2 sine theta. And plus 2 sine squared theta, which you get that one there. Plus 2 sine theta cos theta. And then 1 minus 1 is 0. So you end up with 2 cos squared theta plus 2 sine theta cos theta. You can factorize out for this top part sine theta, one of the sine theta out. And for the bottom part, you can factorize cos theta out because there's cos theta, there cos theta. And then what you find out is this will cancel with that. 2 will cancel with that. You end up with sine over cos, which is tangent. and solve that equation. So if we replace theta with 2x, so we end up with tan 2x would be 3 sine 2x. So sine 2x over cos 2x is 3 sine 2x. And you cross multiply. Sine 2x equals to 3 sine 2x plus 2x. Bring this to the left, it becomes minus. Factorize sine 2x out. So either sine 2x is 0 or cos 2x equals to 1 over 3. So sine 2x is 0, so 2x is 180, so x gives you 90 degrees. And 1 minus 3 cos 2x equals to 0. Solve that, you get 2x is equals to inverse cosine of 1 over 3. And then you divide by 2. 70 divided by 2, 289 divided by 2. So your answers are 35.3, 90, and 144.7. Question number 11. We're going to use the trapezium rule. The main thing here is to identify y0, y1, y2, y3, y4. Substitute it in the formula. The h is 0.5, and to get h is b minus a over n. So it's b is 4 minus 2 over 4, because you want to divide it into 4. You divide it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's 1, 2, 3, 4 strips. And then you substitute the values for y0, yn, and the rest, and that gives you 2.41. And that's the formula for trapezium rule at the bottom there. Part B is integration. And now this is where you got to use integration by parts. So imagine you multiply by 1. It was just ln x all squared. Imagine you multiply by 1. So you would have u to be ln x all squared. Du over dx is 2 ln x. Differentiate with respect to the power and differentiate with respect to ln. And dv is 1. And integral of 1 is x. Put it together in the formula for integration by part. You get this expression. The x will cancel out. X and 1 over x will cancel out. You end up with 2 ln x. You have to do another integration by parts for this 2 ln x. So for this one only, we're doing this integration by parts again. So we let u be ln x and dv be 2. Du over dx is 1 over x, and integral of 2 is 2x. Put that in the integration by parts formula. The x there will cancel with that x, so you have integral of 2. So integral of 2 will give you 2x. So put this together is 2x ln x minus 2x. We take that now and mix with the first part. So the ln x squared comes down. We mix it together with the one we just found to get this new expression. There's a lot of simplification involved here, and all you need to do is to be very careful with your signs and don't rush it, because you can easily make mistakes here. So write it out neatly. So we substitute 4. 4 will go in wherever there's x. And you get that first expression. After that, 2 will go in wherever I see x. You get the next expression. But we know this is what the answer looks like. This is what we want to get. We want to get an answer that has ln 2 squared and the ln 2 in front there. So what we want to do now is we can write 4 as 2 squared so that we can get that ln 2. So change the 4 to 2 squared. And then we will take this power to the front. And then we'll multiply the 2 times 4 to give us 8. And we'll change this 4 to 2 squared. And this 2 times 4 will give us 8. And the second expression is the second part is nice and easy to follow. So after that, we will have 4 times 2 squared is 16. And got the first part, the second part, and put it now together. We've got 16 ln 2 squared minus 2 ln 2 squared minus 16 ln 2. So what we want to do now is 16 minus 2. 16 minus 2 is 14. So it's 14 ln 2 squared. Minus 16 ln 2 plus 4 ln 2 is minus 12 ln 2. And then 8 minus 4 is 4. So our A is 14, B is minus 12, C is 4. Question number 12. We start by writing the expression as a quadratic because that shape there is a quadratic. So we put H, X is 0, H is 3, and we get C to be 3. For the next one, we put X is 120, H is 27. We'll get this first equation. And so got 24 equals to 14,400A plus 120B. And then we do dH over dx. When you differentiate ax squared, you get 2ax. Differentiate bx, you get b. And put it equals to 0. And then when x is 90, you solve it, you get the second equation. So you got equation 1 and equation 2. Simultaneous equation. You put in your calculator, you get a to be minus 1 over 300, b to be 3 over 5. That's what you put in the calculator. You put 14,400, 120, and then 24. And then you put 180, you put 1, you put 0, and you solve it, you get the 2 answers. So that's the equation for H. For part B, you put X is 90 in the expression, you get 30 meters. So you put 90 there, 90 there. Put in your calculator, you get 30 meters. For part B, put H is 0. And you solve that quadratic, you get 185 meters. You cannot have negative distances. So you have horizontally is 185. So that's what you put in the calculator. And then you would get that 185. Part C, the possible effects of wind or air resistance are 2 limitations. Give one other limitation of this. The ground is unlikely to be horizontal. The ball is not a particle. It may have dimensions or size. It may not travel in a vertical plane. It may spin. It might not be a quadratic. So you pick any one of these. Question 13. What we want to do is substitute the value, the expression for X, substitute the expression for Y, simplify it and see if that left-hand side would be equals to 4. If we substitute X, substitute Y, and then we simplify it and get 4, that means it is equal to the right-hand side. That means it satisfies the conditions. So what we do now is wherever we see X, we put that expression. Where we see Y, we put that. So that will give us this expression there. Now, quite a lot of algebra involved here. So we want to do the numerator first. So got t squared plus 5 minus 3. We can put this together as one fraction. The common denominator is t squared. And then from there now we can subtract them. T squared plus 5. So t squared minus 3t squared gives you minus 2t squared. 5 minus 3, it gives you 2. So we've put the first fraction as 1, and we end up with that. Now we put the two of them now together. Use the same denominator, t squared plus 1. So when you multiply 2 minus 2t squared times 2 minus 2t squared, you get 4 minus 8t squared plus 4t to the 4, which is what we'll write here. And then 4t squared, it gives you 16t. So that gives us 16t squared. Now we simplify the top, 4t to the 4 plus 8t squared. 16t squared and minus 8t squared gives you 8t squared and then plus 4. Factorize the top, 4 can come out because 8 is 4 times 2. That's 4 times 1. So when you take 4 out, and then you can factorize this as t squared plus 1 all squared, which would cancel with the bottom one, and you're left with 4. So you have shown that you can change the left side to the right. Question 14, we want to show that dy over dx is equal to that, where a is a constant. So we're going to use the quotient rule. I put the quotient rule formula underneath. So u is x minus 4, v is equal to 2 plus x to the power half. So you find du over dx, find dv over dx, and then we substitute all of that into the quotient rule. So when we substitute that, we get that expression for dy over dx. Now we have to simplify it to change it to that. So you start by removing the brackets at the top there. X times a half, x to the minus a half. So that gives us this first one. And then after that, when you multiply, you get 4, x to the minus a half. So what you want to do, when you simplify it, you want to get rid of the square root of x underneath. So a technique is to multiply everything by square root of x, each one by square root of x. That means this square root of x will cancel with that. And then this one will be 2 root x. This one will be root x times root x. This one will be half root x times root x. This one will just be 2. And this one will be root x times that. Now, to get rid of the 2 in the half there, we'll multiply each one by 2. So this times 2 times 2 times 2 times 2. So this will become 4 root x. So you get that expression. And what you could do from there now, you can write it where it's x, 4 root x, and then 4. And this at the top there is a quadratics, if you look at it that way. Or when you expand the denominator, 2 plus root x, 2 plus root x will give us x plus 4 root x plus 4, which is the same like the numerator. So those two will cross out. You're left with 1 over the 2 root x. So your a is 2. Number 15, use proof by exhaustion. And all the n numbers less than or equals to 4, and they are natural numbers. So try all the numbers. So you try 1, 2, 3, 4. And it gives you sub in 1, 2, 3, and 4. So 1 plus 1 cube is 8. You put 2 plus 1 is 3, 3 cube is 27. You put the next one, 3 plus 1 is 4, 4 cube is 64. And you get all those answers. So if n is less than or equals to 4, then n plus 3 all cube is greater than 3 to the power n. Because 8 is greater than 3, 27 is greater than 9, 64 is greater than 27. The next part, given that m cubed plus 5 is odd, prove by contradiction. So if m is odd, we can use 2p plus 1 to represent m. So wherever we see m, we put 2p plus 1 cube plus 3. Expand this cubic function. You use 1, 3, 3, 1, the binomial, the numbers from binomial triangle. And you get this expression when you expand it. And then when you add 5, you get a 6 there. Now you can factorize 2 out. 2 times that expression there, which is even. But when you multiply by 2, it's in the 2 times table. So therefore, it's a contradiction. If m cubed plus 5 is odd, then m must be even. So thank you for watching this math video, and I hope it helps you. So if you go to the website www.anago.com and you go down to the secondary, you can click on the link that says buy this course. It's not expensive. It's 7 days free trial, and or you can click on the link that says start your free trial. And now all these videos are put in the course so you can watch it over and over. You can pause it, replay it. And the nice thing about this is that whenever you come across a question you don't understand, you now have access to me and all the other professional tutors. You can send me an email. You can send me a WhatsApp. I prefer WhatsApp because I have my phone to always check them quickly. And then I will make a video solution and send it back to you. So by joining anago.com, you're joining a course where you have 24-hour access. It is a premium support. You don't have to wait till the next week to get answer to a question. You don't have to pay a lot of money to get education. It is a course which lots of students have used before, and most of my students have made it to the top universities around the world. And I carry on doing that at a very reasonable price. It's usually cheaper than the price of one lesson to join this my course. And you also have access to me, and you also can book extra tuition in a group or as one-to-one. So congratulations, and look forward to working with you and getting you to succeed in your exams.